Hi, my name is Andy Hahn, and I've worked at the NASA Langley Research Center here in the Systems Analysis branch as an aerospace engineer. I've been associated with NASA for just under 30 years, and I first worked for NASA as a co-op, that's short for Cooperative Education Program, while I was in undergrad. And after working for NASA for a number of years, I actually went back and got my graduate degree in aerospace engineering. What projects have I worked on? Well, it turns out that I've worked on an awful lot of projects over the years, and they've covered a really wide range. My first project was something called the Buoyant Quadrotor. It was essentially a blimp with 4 helicopters on it that was being sponsored by the National Forestry Service. I then started working on vertical takeoff jet fighters, doing mostly systems analysis, which is sort of like conceptual design, or what I like to call designing paper airplanes. We don't actually build airplanes, we just analyze them and report to other people what their performance is likely to be. I then was the lead aircraft designer for the Center for Naval Analysis during their future carrier study. Now this was about 25 years ago, so it turns out that the future is already here. But basically what I did was I tried to project into the future what future capabilities naval aircraft might have and how they might be deployed in the fleet. I also worked at NASA Ames, which is a different center, on the Mars airplane proposal. At the time, the idea was at headquarters that it'd be really cool for the 100th anniversary of the Wright Flyer to actually have an aircraft fly on a different planet, and so I actually participated in that. I also was the government evaluator for the variable diameter tilt rotor. Now most people have heard of the V-22, which is the only active tilt rotor in the world right now, but it has certain capabilities that could use enhancing perhaps, and one of the possibilities was to do something called the variable diameter rotor, and I was the government evaluator for that proposal. I've also done STOL regional jet analysis. Now STOL stands for short takeoff and landing, and the basic idea there was to allow a fairly large aircraft to service a fairly small airport and hopefully bring jet airliner service to many more people, perhaps in lower served communities. And I'm currently working on the environmentally responsible aviation program. It's NASA's big program for trying to improve the fuel economy while lowering the noise and emissions of airliners. And I'm working with Boeing. I'm their technical monitor for their current work that they're doing. But I'm also working on my own concept. I have a patent for something called the overwing nacelle. It's a very different way of integrating a turbofan engine onto an airliner, and I'm using very high-level computational fluid dynamics and structures analysis codes to be able to prove that it works, because right now I'm the only one that does believe that it works, but I need to prove it, so I need to go ahead and do the hard work that's necessary to actually do that. What are the most exciting aspects of my job? Basically, I get to work with really intelligent, really motivated people using very high order tools, something that's really cutting edge, on problems that are hopefully of importance to average people, that also are really cutting edge. You know, making airliners quieter, making them more efficient, making them more available to more people. I just think that's a cool thing to do. And how is my job relevant to STEM? Well, I can honestly say I use, math and science every single day in my job. And while I'm not a pure scientist, pure scientists will use the scientific method to discover new things about our universe, basically. And I'm not a pure mathematician who, discovers new facts about mathematics that are very academic. I'm more of an applied scientist or applied mathematician. I'm not as good as either of those guys. They're very good at what they do. But what I try to do is understand what they've discovered and apply those things to problems that people have, hopefully making the world a better place through advancements in technology.